right, so let's go ahead and look at when we use proportion and confidence intervals. So for number 18, a utility company samples 449 customers and finds that 148 of them have a discrepancy on their service bill. So what is the upper bound of the 99% confidence interval for the proportion of customers with a delinquency on their service bill? All right, so I'm going to go back into WebAssign. And I'm going to use SALT. So when you go up here, remember you're going to go to inferential statistics, choose one sample proportion, and hit confidence intervals, okay? The number of successes, remember, is going to be 148, and the number of trials is 449. And I'm going to make this a 99 because it wanted me to do a 99% confidence interval. Okay. And it gives me what I need. All right. It gives me the lower limit here. I'm going to copy this. I think it'll let me copy it. Okay. Here. Yep. So it gave me the lower limit and it gave me the upper limit. So here is the upper limit that I was looking for right here. And it wants 3 decimal places. So, or let's just do this. The answer is 0.387 because that's 6 rounds to the 7. So that was my answer. Okay. So that's how I do that one. Oops, let me do this. Okay, so number 19. I got off on my numbering again, so it may be different. So, okay, so number 19. So in a random sample, let me clean that out, of 61 professional actors, 22 were extroverts. Find the 95% confidence level for the proportion of professional actors who are extroverts. Okay, so I'm going to go back to SALT. So let me go to it here. Okay, again, I'm here at inferential statistics, one sample proportion. Okay, my number of successes is first because that's my lowest number. So I'm going to go here and I'm going to put in, it said 22 out of the 66. Remember, the smaller number goes first. Okay, come on. Okay, and this one I wanted 95%. Okay. Okay, and then I hit generate results. Okay, so then it gives me again the 95% interval, the lower limit and the upper limit. I'm going to copy those over to my answer sheet so I can compare them. Let's do this. Okay, I'll put it right here. Okay, so all I'm going to do is find the one that's closest. And those aren't really that much closer. Oh, did I do it right? No, I did it right. They're a little bit off. Oh, I messed up. Okay, and this is a good lesson on why you got to watch what you put in there. Okay, I thought it was 66. It wasn't. It's 61. So I can quickly fix that one. So if I go back here and change this to 61, look, and hit generate results, I get the right results then. All right, so I'm going to copy this. Oops. And I'm going to put it here. So that's why it's important to read your numbers because you saw I just did it. All right. And here is the closest, and it's this one right here. Okay. So I'm going to put that here. Okay. So that is the right one because you see 0.240. And this is a little bit off because there's other ways you can do it with. You can do it with a calculator. You can do it with software. So this was the closest one to it. And remember, I'm going to check all these by hand. So just make sure you get the one that's closest to it. Okay. All right, so here's another question. Again, I got off on my numbering, but here's another one for proportion confidence intervals. All right, a random sample of 377 medical doctors showed that 162 have solo practices. As a news writer, how would you report the survey results regarding the percentage of medical doctors in solo practice? What is the margin of error on a 95% confidence interval? All right, so let's go look at this, okay? All right, so I'm going to go back here. I'm going to keep in here, and then what I'm going to do is I'm going to do It said there was 162, and out of the 377, and it said, what did it want? Let me go back and check. It wanted a 95% confidence level. So I'm here and I'm 95, so I generate my results. Okay. I'm going to copy all of this over, and I'll show you what I'm doing. I'm going to copy it actually what it is, just so we can see it. Okay. So I'm going to do edit, copy, and I'm going to put it over, and I'm going to show you what we're going to do. Okay. All right. So here we go. All right. So what it wants me to do is it wants me to look and see what the margin of error is. So if I look at it, I've got N successes, the P, and then the standard error. But don't worry about the standard error, okay? Worry about the P. So this P is kind of like if I was going to look at the average of in the middle of these confidence intervals, and it's around 43%. So that's where we're getting the 43 right here. Okay. So another thing I can do, and I'll show you what this is. Let me go here. Let me open my calculator. Oops. All right. And I'm going to show you how to do the other one. All right. Let me do this. Oops. Okay. I'm going to go here. I'm going to go grab my calculator, and you can do this with any calculator. It doesn't have to be the TI-84 or 85. Okay. Okay, I'm going to bring it here. So what I'm going to do is I'm going to do 0.479679, which is the upper limit, and I'm going to subtract the p hat right here, which is 0.429708. Okay. Do that, and then I get the 0.049971. And if I round that to a percentage, I'd get 4.999, or roughly 5%. So that's where this is coming from right here. Again, the 43 was really easy to get. It came from, oops, let me go back up. It came from here. This is where I'm getting the 43%. But to get the actual margin of error, remember, you take the upper bound, subtract that p hat value, and you get that, and then you make it a percentage. So that's how you got that right there. Okay. And let's do one more. I think we have to do one more. Oh, no. No, we did it. We don't have to worry about this one because this one was a different one. All right. So let me see. Oh, yeah. So those are the proportion ones. So let me know if you have questions about those.